Welcome to the second part of Chapter 4 Requirements Engineering RE. This is your instructor Malik Harbawi. So we will cover during this session goals and requirements, usability requirements, requirements engineering processes, and requirements elicitation. The goals and requirements. If you remember, last session we discussed non-functional requirements, and we said that actually these are not very easy to deal with, and they may create some conflict when we start implementing them. And due to that, they are actually at an extreme importance when we develop a software. So in brief, the idea of non-functional requirements usually creates some issues while even developing functional requirements. Let's just see the idea how these things or how this kind of concept is applied in real world. Let's say we have a goal, okay? And this goal is an extremely general statement which can be identified as an intention of the user. So just the intention of the user or the customer, end user of a software, or the client who is asking for the development of the software. All right. And in this case, we may have a way to verify this objective, or we may not, based on what the client or the customer says. And we will see how. You may tell me, what do you mean by verify? Basically, we have a statement, an objective, or a goal, a target. And this objective or target or a statement requested by the user as actually a targeted, you can say, aim, or something that the customers or the users are looking for to have in the software. All right. Well, in order for us to achieve it as developers, we need some metric to measure, or some, you can say, measurable quantity to see whether we can achieve the objective or not, whether we can achieve the goal or not. So we need some sort of test, and when we need test, we need a measure, and this is what we refer to usually by a metric. Okay. Well, in the idea of stating or describing the goals, actually we can understand the intentions of the user or the customers of the system, and in that case we try to build a correct understanding. However, we need some sort of verifiable measure. Well, for today's session will be actually based on these two statements, the goals and the testable measures and things related to them. Let's be a bit more precise and focused. Now look at this. I'll just read two statements and you will see. The system should be easy to use by medical staff and should be organized in such a way that user errors are minimized. Well, this is a goal from, let's say, care system, or the mental care system, the mental health care system. We explained about it in previous sessions. Well, this is a goal, okay, but it's too general. How can we exactly measure? Well, how can we test whether the system is easy to use? Well, it's extremely broad in sense of usability. How can I testify? How can I exactly understand or say or claim or prove that it is usable? Okay. Well, when we say in such a way that user errors are minimized to what? Which level? So let's go to the testable non-functional requirement. Medical staff shall be able to use the system functions after 4 hours of training. Well, that's the difference. Well, here, easy to use is just a plain statement of a goal, okay? But if we transfer it in another way to a measurable, you can say, target, we will have a testable non-functional requirement. Easy to use or usability is a non-functional requirement, but how to measure it? Well, we can set certain time for training, and based on it we say, well, We have to measure if the system can be learned by normal medical staff in 4 hours, then well, it is easy to use, or maybe 2 hours or 3 hours, or maybe 2 days of training. It's possible, it depends on the system. But we have some measurable amount or some metric to put our target or stage against. So after this training, the average number of errors made by experienced users shall not exceed 2 per hour of system use. Well, here we say in such a way that user errors are minimized. Minimized to what? To which level? So here we can say it in another way that makes sense to us, metrical sense, something that we can measure. So after this training, the average number of errors made by experienced users shall not exceed 2 per hour. Well, we can measure 2 per hour. Here we cannot measure minimized. Minimized means what? 0 per day or what? So maximum 2 per hour. Well, so now you understand the difference between a goal, so what the user intention is telling us, and a testable non-functional requirement. So this is usually the main idea when we have non-functional requirements and we need to create some sort of measure related to them. Now look, well, we have different types of metrics for non-functional requirements. As we said earlier here, we have like 4 hours of training. Well, this is a metric, so we speak about time, learning time or training time. So it's time. We have some measure. Now think about other, let's say, metrics that we can use for non-functional requirement. Let's say we speak about speed. Speed, well, maybe you are discussing the performance of a software. Where you say it should be quick. What do you mean by quick? Quick by processed transactions per second. So how many transactions per second we're supposed to process using the software? Or user event response time. Well, if the user is initiating an event, whatever the event is, it doesn't matter, opening a window, processing data, anything. How long the response time should be? Well, millisecond, 1 second, 2 seconds, 5 seconds. So there should be some metric to measure. How about screen refreshment? Or when we refresh the screen, the time is taken to refresh the screen. So this is about speed. Maybe we think about performance from these perspectives. Maybe other measures could be listed. It depends. So it depends exactly what you are measuring and for what you are measuring it. Size. Well, you may think about a software, you say as a user or a customer, or maybe a customer or user is telling you it should be small in size. So you say, well, small is too broad, it's too general. It's just a goal that you are telling me, but specifically based on the measure. So measurable amount, something that I can test. How small are we speaking about? Megabytes? Kilobytes? Maybe kilobytes. It's not possible, maybe. If it is a tiny program, well, it could be, but are we speaking about some sort of megabytes or gigabytes maybe? Or how about if you think about another way? Maybe you need to use some certain number of ROM chips where you store the program on, or install the program on them. Maybe the client or the customer has limited number of ROM or would like to deploy limited number of ROMs to install the program. So it could be also the measure. Easy of use. So the easiness of use depends on the training time. Okay. Also the number of help frames. Well, how can we manage later on maintenance if there is any problem, or maybe some other, you can say, technical assistance later on after installing or after delivering the software to the user. Reliability. Well, reliability is a very broad and important non-functional requirement where we assure our software is running with, you can say, a tolerable number of faults and failures. So we speak about faults and failures. The first thing comes to our mind, mean time to failure. Mean time to failure means what? Actually, we can usually, most of software applications, run with no fault. They have no problem running. However, if a fault happens and then a failure in the program is occurred, what do? We calculate the time from the last failure until the time that failure happens plus the fixing time. Usually this is an extremely important metric. We call it either, actually not mean time to failure, we call it mean time between failure. So mean time to failure plus mean time to repair. So this one usually is referred to, you will study it in another course related to software quality, MTTF. We have also MTBF. We have also another time to repair, MTTP. So that's another factor, or you can say metric that we usually use. So this time is at a critical importance while dealing with the software. So we can count it, and it has also relevant applications. Another factor of measuring or setting up a measure for the reliability, probability of unavailability. Well, if our software goes unavailable, that means we cannot use it at the moment due to some repair or some stuff. How long are we speaking about, or how many times can we get such a thing? Let's say maybe once in a month, once in a year, or something like that. Rate of failure occurrence. Well, how many times, let's say, per month? How many times per year? Or rate, percentage. So we calculate all the normal operational time, then we calculate the time of failure, and we get the percentage, the rate. Also the availability. Availability is exactly the opposite of unavailability. Unavailability is not the normal operational process of the software. This is the normal operational process. These things usually are used as metrics for software quality. You will study them in other courses, but now you will understand at least the basic idea of them. Robustness. So robustness is actually how is also sort of quality measurement of the software. Time to restart after failure. Well, let's say I have a failure and my software is actually stuck and I had to restart it. How long it takes to restart and recover? Then maybe the percentage of events causing failure. Do I get this failure too often, or is just once in a while? Because we cannot have a software that 100% pure of failures or errors. That's not usually the case. So there is a probability that we may have some human error that causes a failure in the software. That's possible. And we face it. We face it usually at least like a couple of times a week, maybe a couple of times a day. It depends on our way of usage. Also, probability of data corruption. Let's say I have a failure. My software got a problem and it's like restarting, or it's deviating from the normal norm of operation. Then, do I have a problem with my data? Like now I'm working on something in the software, and let's say I stored some of the data and some other part of the data is not stored. Do I get a corruption in the data, stored or not stored, the one that I'm working on? So this also matters. Portability. So for the portability, we may think about the software. How many targets can we install the software without any change or without any modification? This matters. Well, how about, this is the number I said. How about the percentage of target dependent statements? Well, if you want to create a portable software, then you need to think about the statements that you use, or the codes that you use in order for your software to be portable. Then you think about those and how actually you can fix the code of your software to be portable. That also matters in this regard. Okay, that's enough for these. Let's not extend. Requirements engineering processes. Well, requirements engineering by itself has its own processes or stages, if you would like to call it. Okay, and actually these processes depend. They have their own way of anticipation and visualization. Well, they are visualized based on application domain, one of the factors or one of the you can say, dependency that we usually think about while considering these processes. Also, the people involved, those who are involved in the requirements engineering, plus the organization itself. So the organization that is developing the software or working on the project itself, well, these processes depend on, maybe more or less it varies. However, we have generic, you can say, steps or processes that most of companies bind with more or less. So requirements elicitation is about discovery. Elicitation in this case is a bit similar to discovery. So we discover the requirements of the software from user perspective, from system perspective. Then we have requirements analysis. We have already discovered the requirements. We need to analyze them and verify and see. So we need to analyze, then validate whether these are the requirements that the user or the customers are asking, and whether they are applied to the system that we are developing or not. Requirements management, then we have also a step to manage these requirements while development or during these development, and also prior to development. So it matters in case of let's say the priorities, whether we can manage also the requirements set, whether they are feasible or not. All these things matter in terms of management. So how about those? Do they come in a sequence? So we need to do the requirements elicitation first, then analysis, and so on and so forth? No. Usually these stages or processes are interleaved. What does it mean? That means we usually do them at the same time. Not exactly all of them at the same time, however, they are interleaved. So we may have elicitation and analysis, or some of the elicitation intersects with analysis, some of the analysis intersects with validation, and so on. This is what it means. We have a spiral view of requirements engineering process. This is extremely important. Why? It shows you how these are interleaved. So as you can see, when we start, usually we deal with business requirement specifications. So we think about the business requirements. And once we set these requirements or the specifications of the business-oriented ideas or project, we see the feasibility study. Whether this thing is feasible or not, we can build it in reality or we cannot within the budget and time frame. If it is yes, then we go to user requirements elicitation. We try to understand users' requirements, and we see how we can achieve them. Once they are done, we create something we call user requirement specification, and this is usually a document. Usually this document is also attached to another part, which is the system requirement, actually. But for user requirements, we have certain type of documents, and we have actually ready formats that usually companies use. And this will be our first assignment. I will share it soon enough with you about the first step of our project. Okay. Usually this kind of requirements engineering process is also involved in prototyping. If not prototyping, it could be also agile development step. So one of these two. Once this prototyping is done, maybe we can think about the total requirements elicitation done. Also, we can think about, next to that, the system requirements specifications and modeling done. Then we can validate all of them. So we can validate the the user requirements and the system requirements, and come up with the final reviews. So the outcome here actually is a document. Usually for user requirements, we do not actually specify one separate document. No, rather we put them together with the system requirements, and sometimes with prototyping. And you remember, prototype is actually a draft version of the software. So we disregard many of the functional requirements. We just build like a skeleton of the software and discuss it with the customers and see their views, whether they are happy with the current prototype and what kind of maybe view they have on this prototype. And maybe you will tell me, okay, but there are no functional outcomes of this prototype. Specifically for this reason, we prototype the software to see the opinion of the customers or the users, so that we get functional things put together with no or with less mistakes. We cannot say with zero mistake. That's usually not the case. We may have to have margin of tolerance from both parties. This is available in software industry. So after all these steps, the requirements elicitation plus the requirements specification and requirements validation, we will come up with system requirements document. It's an official document. It's like a contract between the development company and the client of the software or the customer of the software. So we mentioned earlier about the elicitation. It's about discovering actually the requirements of the software itself. What does it mean? We discover what the software is supposed to do, okay, and based on which constraints it should operate. So from where we will get it, from where we will understand this, these requirements and constraints, we need some technical people to cooperate or work together with customers. So customers usually we refer to stakeholders of the software, those who are involved with the software by some way. That means those who are asking the software from the company side or the client side, not actually the engineers who are doing it. We need the engineers who are actually, or the requirements engineers, to cooperate with customers or stakeholders from the company side to understand what actually they want. So they understand what? Application domain. Maybe the services the system will provide or should provide, and also the operational constraints. We spoke about the operational constraints. You may think about on which environment the software will be installed, or whether it should be compatible with different environment. How about the size that it should occupy? How about the performance and so on? So what kind of input and output? All these things. Well, as I said earlier, we need to involve stakeholders. So stakeholders, actually, we explained about it in the previous session, that anyone who is involved with the software, it could be end user, it could be manager, engineers who are actually in charge of maintenance, domain expert. Domain expert means what? Well, we are, when we discuss about developers or those who are in the software industry, we speak about technical people. Well, technical people usually do not understand much of other fields other than their own fields. So if we are to develop software for social science applications or medical use, well, what do we know about these fields? Extremely little. So in that case, we will need some domain experts, some people who can link us to these fields, explain to us in our own terminology so that we can understand. Maybe trade unions, things related to, software and ethical committees and so on. These are stakeholders. We mentioned about it in previous sessions also. Well, as I said earlier, in order for you to understand or fully understand the application domain, you need to work with a lot of people, a lot of stakeholders. Why? Because discovering a big software's purpose and how it should operate is not an easy process. You will need to understand things related to the performance or the sought performance of the software. What kind of performance are they expecting from the software? Also the constraints under which or the conditions of the operational conditions of the software. Or what kind of systems the software should depend on, or what kind of system, what kind of operational environment the software will rely on while operating, and so on. There are other things that we need to discuss and consider while discovering the requirements at the beginning. Well, what kind of stages do we have? The first one is requirements discovery. Okay, the next one is classification and organization. The third one is prioritization and negotiation. The last one is specification. Specification is actually we are done. We set the final stage of putting all things together. After discovery, classification, prioritization, and negotiation, we put everything together in terms of a formal, you can say, document. All right. What kind of problems do we usually face with the requirements elicitation? Now think about this. Sometimes some stakeholders or clients ask for a software, but they are not quite sure what they really want. It's true in many cases. They may explain to you, but not exactly what they want. They explain to you something that seems to them that they want it, but it's not reality of what they are looking for. Maybe stakeholders know exactly what they want, but the problem is they explain it in their own terminology. And as I said earlier, we are not specialized in each and every department's terminology. That's not possible, and nobody can master it. Well, we may have conflict between the stakeholders' requirements. While some of them ask you certain requirements A, and others ask you requirements B, or some certain requirements in another domain or other you can say aspect, but they are conflicting. It's possible. This is possible. Some stakeholders may take or may request or may set up some requirements to increase their influence in the organization. This is possible, and that may create a problem. Also, requirements themselves possibly change during the development process, or during also the setting up the requirements, creating the requirement specification document, or the document needed for these requirements. So during the analysis process we may change, or maybe new stakeholders will emerge in the business environment, and due to that we will need to have some new requirements or set new requirements, and that's possible. These are also problems that we usually face. So I said earlier about the elicitation, and the elicitation process has these 3 steps: requirements discovery, 4 steps I said, sorry. And next to it, this is initiated by requirements discovery. Then after that, the classification and the organization. You see, this is the movement. Next to that is the prioritization and negotiation, and next to that, the final stage, the specification. Usually we may need to loop. Not once, not twice, it depends, until we reach to a refined requirement specification. That's why you see it's like going to a circle where we may cycle like, a number of times. It depends until we reach to the specification. However, remember that change at an earlier stage is not as expensive as the change after we set up the requirements and start building the software in you can say programming way. We start setting up the executable files, and that at that level, or at testing level, the change will be much more expensive than now. Expensive means what? Time and budget. It will consume a lot of time. Maybe it will need to recruit new or extend the contract of those who are dealing with the development process. The activities. So I explain about those. Actually, I don't need to give more details. Just to quickly go through, for requirements discovery, we need to interact with stakeholders and understand the requirements and clearly come up with mutual understanding, or at least some agreement between the requirements engineers and the stakeholders. Next to that, we need to classify and organize the requirements that come in some way similar to one another. So we need to cluster them and set them beside one another. Then next to that, we need to prioritize. That means create a priority for each of these classified requirements. Which one we should do first? Because not all requirements have the same priority. These requirements, some of them should come together so that we discuss when we set them with the stakeholders once we start, you can say, the development process, even before. But just setting them up in the requirements document as first or higher priority than others is an extreme important, because, as I said, they are not equally important for sure. Specification. Finally, as I said, all these things will be the document that we need to use as a contract between the company or the development company and the client of the software. I explained about software discovery. Just one thing I have to mention. I mentioned about dealing with stakeholders. We need also to check previous systems. Maybe the client or the company that's requesting the software from us have their own existing systems. We need to discuss them or check them and see what we can do to improve the current systems or to come up with an idea to overcome the issues with previous systems. Well, we may need also to discuss with some external regulators, and these are also stakeholders for some reason, okay? So the idea is we need to have like a range of stakeholders, not to discuss with one end user and that's it, I have discovered the requirements. That's not possible in the software industry. You would just come up with a complete failure of a software ultimately if you are just taking the opinion of one person or an end user. So how do we discuss with these people? What kind of method do we use to discuss with the client or the stakeholders of the software? Interviews could be a good beginning. Interviewing the stakeholders is actually the process of creating an idea based on questioning the stakeholders. So in that case, we may have different types of interviews or sessions of questioning. The closed interviews actually, you set up all your questions, a list of questions. Maybe you can send them in advance to the clients or the stakeholders, and then you come on certain date or certain time, discuss all these questions with the clients, so they have an idea and they answer your questions, but they have to be predetermined. That's the closed interview. Open interviews, you come to your client or customer and you sit with them and ask whatever questions you have in mind about the software, so that you have no predefined questions. Usually in reality, we have a mixed type of those closed and open interviews while trying to understand the requirements of the software. Well, what kind of criteria or characteristics do we have, or characteristics do we have while interviewing people or interviewing customers? Actually, we should be open-minded. This is the first thing. And we should not have pre-ideas in our mind. We need to understand from the client side. We shouldn't convince them by our own ideas. Well, we can discuss with them, yes, but we shouldn't have our own perceived ideas and just get stubborn while discussing with them, okay? And we should be willing to listen, not just impose our own opinions. No, we should listen more than talk, try to understand to their remarks and comments about the software and what they are looking for. Because ultimately this software will be their own software, not our own software. Well, sometimes for some reasons the customers or the clients of the software cannot get the discussion going. So you as an interviewer of the session should get the discussion going. What does it mean? Well, use whatever technology or whatever tool you can use to get the the interviewee answer your questions or get interacted with you. You may suggest things, you may propose things, you may use a prototype or bring an existing system and ask, how about if we do this way? How about if we look into this and we improve it? Maybe the system would work for you. How about we add some specific parts to it? Well, this is the idea of conducting a successful interview. Okay, interviews in practice, as I said, usually it's not just one type of open or closed. No, it's mixed type of both of them. Predefined questions and open session for question and answer. The idea of interviews, actually, we can get an overall understanding of the software from stakeholders. But the problem that we usually face with interviews, as I said, sometimes mismatch in understanding. Let's say we in the technical field, we may not understand well how non-technical people think or look at things. So it comes to their own way of explaining things. That may be a problem. As I said, one of the key points for interviews to be successful, that we need to be open-minded. That means we need not keep any ideas or have our own predetermined ideas before we understand from the clients or the customers. Okay. So one more thing, as I said, try always as an interviewers as interviewers try always to keep things going. Maybe you can suggest things, maybe you can explain things, maybe you can provide an existing example to the client so that they can come up with their own or try to explain to you. I mentioned about one problem in interviews, but usually this is not the only problem. I said earlier, when we speak about some specialists in the domain, let's say I usually give this one as an example, and people even ask me, why do you give this example? Because such a field like medical discipline or medicine is a bit far from a technical aspect, and usually only specialized people understand its own terminologies and things. So when you speak to a medical specialist as a technical person coming from a software engineering or something like that, the common language between both parties usually have a huge mismatch. Well, he may speak to you by his own jargons and terminologies, and you will just not understand what he's telling, and that's a big problem. Well, such a gap may create a problem. So we have this like mismatch of description from specialists or those who master their own application domain too much, and then they come and explain to a technical person from software engineering or software development team or whatever. One more thing. Actually, interviews are not good for understanding domain requirements. Domain requirements, as I said, usually have their own understanding. Well, and in order for you to understand this domain environment, you have to be involved with it by some sort of way. Well, in this case, how a technical person will understand and have deep knowledge and maybe a very specialized non-technical knowledge, and that's a problem. It's not that much easy. One more thing. Well, let's say you are speaking to a specialist and he's not using his jargons or terminologies. He's willing to explain to you in simple words that you both have in common. However, he's unable to clearly or precisely articulate what he is willing to have in his own system. And that's normal. That's normal. Maybe you, because you have some technical knowledge, you understand and say what you want exactly from a software and what you are expecting from a software. But a non-technical person who is not dealing with the software other than just using it will find it difficult to articulate and explain what he is willing or what they are willing to have in their own software. Ethnography. So this is one of the solutions that we have to link non-technical, usually knowledge to technical people. Usually we have some sort of, you can say, social scientist or a person who has interest in social sciences, remains with some working environment as a normal person who's working there and observes and sees how the work is done. If you live and remain in some environment for some time and watch and observe how people do work, and you have some sort of knowledge in social science, then you will understand clearly how the work is done more than those who are doing it, because they do it out of routine most probably, and it is to them like steps, like an algorithm, steps that they do every day. So this is the idea. If someone comes from an outer, you can say, environment and remains within that environment, what happens is exactly this person will have a better observation than those who are inside. And this is the concept of ethnography. It's applying an observation way of the work environment via a person from outside who has some sort of social, you can say, knowledge or interest. Okay? So this person may come up with how exactly the work is done and what kind of requirements the work dictates or needs or requires. And that's a very good thing to facilitate the gap between technical people and non-technical people when they try to make a mutual understanding of the requirements. So what is it all about, this ethnography? Can we get some information from it? As I said, yes, true, for sure we can get. And one more thing, actually studies which are already done in the ethnography shows that the work itself is much more complicated and richer than what people usually design or explain by simple words or models. And that's why we have so many hidden factors that you can understand once you get into that environment. All right. So what kind of application or scope the ethnography may have? Well, we can have this ethnography to understand how the work is actually done, not by description, by just reality, not those who come and define to you, okay, we need software to do this and this and this to us. Well, maybe your understanding or your explanation is not adequate. Let me see how you are doing your job, and then I will judge and decide if it is ready from some scientist or some specialist who is watching and observing people doing their work. It would be much better in that case. So one more thing, also the requirements derived from cooperation usually require someone who has no bias in that business. What does it mean? It means someone from outside of that business to tell exactly what those require. We may have it as a routine. What does it mean? Let's say you are an employee and you have your friend, your colleague, who's an employee with different duties, but with you. You clearly understand the duties of your friend. So if your friend is not around or your colleague is not around, you can cover his duties. And in that case, you assume that this is just a preset thing or a preset, you can say, application. And you may not explain it. Maybe this is not what exactly requested by the software. However, it's a rhythm that the developer may know or may need to have as an idea of the development. Well, one more thing. Ethnography itself may discuss or understand or give a perspective about things that exist, but not things that actually are going to be discovered or built. So we have existing, you can say, processes, we can understand them, but if we are going to have new features or new understanding of a new problem or a new system, ethnography will not help you to do so, because studies people at work, these features are not there, so who's working on them? Nobody. Okay. Focused ethnography, the idea of focused ethnography is just, you can say, a subdivision of ethnography itself when we have some sort of ethnography with prototyping. It was actually proposed for air traffic control. And when we combine ethnography and prototyping, we'll have much better understanding of the whole problem. Well, we may get unanswered questions. Let's say we tried our best to interview clients. We came up with some understanding. Also, we put someone with them at work and he observed and brought us some other understanding. We put all of them together. However, we still have some questions. How about if we prototype the whole system and then we come and have a new discussion with clients? Well, that will do a much better outcome for sure. Okay, so we explain about this issue. One thing, well, one of the problems also with ethnography is sometimes we may go for, you can say, a historical background of a system. When we watch people at work, maybe this is not exactly what they want us to develop. They want a new theme or a new style of their own job, and this is a problem in ethnography. This could be also a problem. Okay, this is the focused ethnography. Well, we have some sort of, well, ethnography analysis at the beginning, just watching people how they work, and maybe you can have some debriefing meeting or whatever meetings. Then after that, you come up with your understanding of how people work, and get some sort of proposal for the prototype. So you have the generic system development. That means you have some requirements which are set to come up with a prototype. Once you get your prototype, you can evaluate it. You can ask the clients to come and comment on this prototype. Stories and scenarios, another aspect that helps us to understand the requirements from the customers or clients. Scenarios usually actually and stories are actually real life examples that people have already met or faced while dealing with the software. So, well, what does it mean? Maybe some companies or some clients are asking their development company or the company that developing a software for them to overcome an issue that they have. So they tell them, okay, explain to us the scenario you had so that we can come up with a better understanding of the software. And this is exactly a scenario that they have, or a story, a previous story they had with their software. And they can explain it and they say, okay, we are trying to get the software to overcome that issue. We had this kind of bad experience about this and that. Okay, so it's easier for someone to narrate a story or a previous experience to someone else. It's not difficult. So maybe you can think about practical situation. Well, you try to run a software and this happened. You entered some data and this is the outcome. You can explain it in details and that will be a story. Okay, how about scenario? Well, a scenario actually is a structured way of narrating a story. What does it mean? Story may be just fuzzy when people mention it. But if we make it in a scenario like movies, where you expect to have like an introduction, beginning, some events in the middle, and some conclusion at the end. While a scenario may include something like this: description of the starting situation, how things initiated, also the description of normal flow of events, when things were just moving fine, like, okay, my software was running fine like this and this and this and this. While a description of what can go wrong. For some reason this went wrong, for some reason this created a failure or something. How about the concurrent activities that are done together, things like that you can explain about while narrating your own story or the story of a use of a software. Also, when things done, finished, like the conclusion, as I mentioned earlier, like the beginning and the middle events and then the final or the conclusion of certain event, that's the scenario. Well, this is the end of this session. And soon enough, I will upload a task for your project, and I'll upload also an assignment. This will be a duty to make some research and answer some questions. And also I will upload the document about the specification document. It's a formal document. And I'll mention to you about your project, what kind of steps you will do. Okay, until then, have a good time. Goodbye.